We are now starting paper 4 of mechanics. It is February March 2024 9709/42. Timings for this paper is 1 hour 15 minutes and the total marks of this paper is 50. We will start questions one by one. Question number 1. The displacement of the particle at t seconds after leaving a fixed point O is s meter. The diagram shows a displacement time graph which models the motion of the particle. The graph consists of 4 straight lines segments. The particle travels 50 meters in first 10 seconds. Then it travels at 2 meters per second for a period of 10 seconds. A particle then comes to rest for a period of 20 seconds before returning to its starting point when t is equal to 60. Find the velocity of the particle during the last 20 seconds of its motion. Sketch the velocity time graph for the motion of this particle from t is equal to 0 to t is equal to 60. Since this graph is between the distance time and we have to calculate the velocity in the last 20 seconds. So this is the region where we are going to calculate the velocity of that particle. But it has traveled 50 meters in first 10 seconds. Then from 10 to 20 seconds, its speed is constant. That is 2 meters per second is given there for this part. We know one thing from this calculation that if we know that it is, let's say, A, B, C, and D. So from A to B, the speed is constant, which is 2 meters per second. For A coordinate, it is 10 and 50. For this B coordinate, it is 20. And let's say it is S distance there. And the speed there is 2 meters per second. So we can use the gradient formula there. S minus 50 divided by 20 minus 10 is equal to 2, or S minus 50 over 10 is equal to 2, or this implies that S minus 50 is equal to 20, or S is equal to 70 meters. So it has traveled up till here. The total distance traveled by that particle is 70 meters. So for this P coordinate, it is 20 and the distance traveled there is 70 meters. For this C, it has not traveled any distance. So it should be equal to 40 and 70. And for this position D there, the coordinates of this will be 60 and 0. Now, we can use the distance time formula for this portion for the last 20 seconds. We know that we are going to calculate the velocity of that particle. V is equal to 70 minus 0 over 40 minus 60. Or that thing is equal to 70 over minus 20 or this thing is equal to minus 3.5 meters per second. This minus indicates that it having the velocity negative there in that portion from C to D. In the next part, sketch the velocity time graph for the motion of that particle from 0 to 60 seconds. Since now they are talking about the velocity time graph from 0 to 60 seconds, so we will make this graph like this. Let's say it is origin. This is velocity and this is negative velocity. This is the time taken for that particle there. From 10, 20, 40, and 60 seconds. In the first 10 seconds, the velocity is here. If we have to use this coordinate system there, from O to A, we know that the velocity is equal to the gradient of this is a constant. So it should be equal to, for A coordinate, it is 10 and 50 there. And for this, it is 0, 0. So it should be equal to 50 minus 0 over 10 minus 0, and that is equal to 5 meters per second. So let's say it is 1, it is 2, it is 3, it is 4, it is 5, it is minus 1, minus 2, minus 3, minus 4. So from first 10 seconds, the velocity is 5 meters per second and it's constant there. So we will use up till here from 0 to 10. Then from 10 to 20, its speed is shown there, it is 2 meters per second. So for this portion, it is 10 to 20. Then the next part from 20 to 40, it is at rest. So this is the graph of this from 20 to 40. And from 40 to 60, the speed is minus 3.5 meters per second. So minus is this, so this is 3.5. So it should be equal to, from this to this part, it is minus 3.5. So this is the velocity time graph of this question number 1 for this part there.